Hello. In this lecture, we're going to discuss the normal distribution. So here's the outline: normal distribution, properties of normal distribution, standardization and Z Score, computing normal probabilities and percentiles, confidence interval for the normal mean. So the normal distribution is often also called the bell-shaped curve. It's the most popular probability distribution for continuous variable. And the shape of its PDF, the probability density function, is like an upside down bell, so bell curve. And the normal distribution PDF, remember the PDF of a continuous random variable is a complete description of its random behavior. Okay, so the PDF of a normal distribution is shown in the graph on the right. So this is the mathematical formula for that function. And it is completely determined by two parameters: the population mean, mu, and the population standard deviation, sigma. So although it is a function, but it's completely determined by two parameters. In normal distribution, the CDF, the cumulative distribution function, basically it is a function whose value is the probability of a corresponding continuous random variable has a value less than or equal to the argument of the function. So mathematically, it is f of x equal to probability of the random variable x less than x, and which is the area to the left of x under the normal curve. And the normal distribution, why is it so popular? It just pops up everywhere. I'm sure you have heard or seen the bell-shaped curve somewhere. Many measurement processes lead to normally distributed data, for example, the IQ, height, weight, blood pressure, and many others. Okay, they just naturally occur, everywhere. And there's a reason for that. That is called the central limit theorem. Okay, the central limit theorem says draw a simple random sample from a probability distribution, almost any probability distribution. When the sample size is large enough, the distribution of the sample mean will follow a normal distribution. Okay, so this is a very remarkable law of probability. I just said because you can start with almost any probability distribution. Doesn't matter it's categorical, discrete, or continuous. And you draw a random sample, you calculate sample mean. So sample mean is the random variable itself. And if the sample size is large enough, the sample mean will have a normal distribution. Okay, so this is a really a very deep result that characterizes the laws of probability. Okay, so and in the real world, there's many processes that actually summarizing or averaging measurements. So that's why we see normal distribution pop up everywhere. Okay, and once we have the normal distribution definition, we take closer look. There are properties of the normal distribution. First, we noted that the mean equal to median equal to mode, and it's bell-shaped and symmetric, and total area under curve is 1. That's true for any PDF. Okay. And then there's also the empirical rule. The empirical rule, also called the 68, 95, 99 rule, states that the probability for a normally distributed random variable to fall within 1, 2, or 3 standard deviations of its mean is 68%, 95%, or 99.7%. So on the right, you can see the graph actually illustrating these properties. Okay, So this gives you a quick way to actually gauge or estimate some of the probability related to the normal distribution. And then standardization and Z score. Okay, and there's a very special normal distribution called the standard normal distribution. We use the capital letter N and then 0, 1 in parentheses. N0, 1, we call the normal distribution, the standard normal distribution. It has mean 0 and standard deviation of 1. And any normal distribution can be standardized into the standard normal distribution. So we can transform any normal distribution into a standard normal distribution. And the process of doing that is called the standardization. Basically, you subtract the mean, then you divide by the standard deviation. Okay. So the formula is z equal to x minus mu divided by sigma. So if x follows a normal distribution mu sigma square, then we calculate z equal to x minus mu divided by sigma, then z is called the Z score. Okay, and z will follow a standard normal distribution. And if you want to find out how to calculate a Z score in SPSS, please watch the video link there. And how do we calculate normal probabilities? In general, standardization can be used to compute probabilities related to a normal distribution. So basically, if x follow normal distribution mu sigma square and z is the Z score, then we want to calculate probability of x less than a. This equal to probability of z less than a minus mu divided by sigma. Okay. So as long as we can calculate probability for the standard normal distribution, we can calculate probability for any normal distributions. So here's the process. You can standardize and then use the Z table. That's one way. The PDF file for the Z table is also uploaded in the Canvas course. And you can use software like Excel or SPSS. Here are two videos showing you how. All right. And then there's a very interesting concept called percentiles of the normal distribution. So it's a little bit abstract to define. So a percentile is a point in the data in which 1 minus alpha percent of the data points lie below this point. Give it a very easy example is the median. It's the 50th percentile. So basically, when you are at the median, then half of the data points are below you, or half are above you. Okay, so that's the median, the 50th percentile. And a percentile is also called the inverse probability. Here are two videos talking about the concept. And if you want to compute percentiles of the normal distribution, for standard normal, you can use the D table. You can also use technology. Here are some videos you can watch. And also in the Canvas course, we have demonstration files there for you to learn the process. And the last topic is confidence interval for a normal mean. Okay, it is possible to calculate a confidence interval for the mean of a normal distribution. And on the right-hand side, you can see 100, 1 minus alpha percent confidence interval of the population mean for a sample of size n taken from a normal population with variance sigma square is given by x bar, that's the sample mean, x bar minus z sigma divided by square root of n, and the upper limit at x bar plus z sigma divided by square root of n. Okay. The formula is shown in the graph on the right. For different confidence levels, z is chosen from the standard normal percentiles. Okay, so you can have, for example, 90% confidence interval. You can have 95% confidence interval. You can also have 99% confidence interval. Just choose the alpha level you want. So confidence interval for a normal mean, for example, if you want a 95% confidence interval, then we decide the alpha 1 minus alpha equal to 0.95, so alpha is 0.05. Then the percentile is 1 minus alpha over 2 because it's symmetric. So the total area is 0.05. Then on the left-hand side, it's Z alpha over 2, okay? Negative Z alpha over 2. So it is 1 minus 0.05 divided by 2, which is 0.975. The percentile, which is 1.96, okay? So this is how you calculate the Z for the confidence interval. And here's a table which is very convenient for us. It has the percentiles for standard normal distribution listed here. So have the 50s, 75, 50s, 90s, 95s, 97.5s, and the 99 confidence level.